Okay, let's give you guys some practice now. So given 3 points, 1, 2, 3. So given these 3 points, you're going to always be able to form yourself a plane. Work out the equation for this plane. So press pause and have a go. Okay, so to do this, let's center our universe to be at B. You could center at A or C, but let's just use B. So with 3 points, we can always create ourselves three vectors. Sorry, two vectors. So one vector here and one vector here. So from B to A, if you're currently at B, how would you get to A? If you're currently at B, how would you get to A? Here, you would need to move 2 back in the negative direction. Because if you're here, if you are here, how would you get to A? You would need to move back two steps, and then 0 in the Y direction, and then 1 up in the Z direction. So from B to A, it will be given by this. How would I get from B to C? Well, currently I'm at B. How would I get to C? Well, I need to move. Well, currently I'm at 2. I need to move back 2 places in order to get to 0. So this, take away this, would be -2. Currently I'm at 0 here. How would I get to 3? I need to move, if I'm currently at 0, I need to move three places to get to 3. And then currently I'm at B. How would I get to here? Well, I don't need to move anywhere in the Z direction. So that would be 0. So the vector BA is given by this. The vector BC the vector BC is given by this. So now we've got ourselves two vectors. If you have two vectors, if you blindly compute the cross product, it will give you the normal vector. So compute the cross product. It will then give you the normal vector. I'm just gonna guess the normal vector to be it will look something like this. So now let's just compute the cross product. Computing the cross product will give you the normal vector. So computing the cross product, your eyes should zoom into this, discard, look at these 4, and then your eyes should zoom into this, discard, and then should look at these 4, and then your eyes should zoom into the K, discard, look at these 4, and then now the determinant, this times this, take away this times this, that will be 3, and then this times this, take away this times this, so that will be 2, because you've got a, well, think about it, and then this times this, which will be 0, take away this times this, so that will be, hang on, let me think. Yeah, and this times this will be 0. Take away this times this. That will be -6. So that will then give you +6. So that will then give you this. So this is our normal vector. So let's go back a few steps. We've got vectors BA. We've got vector BC. Compute the cross products. That will then give us the normal vector, which is this vector here, because we've just computed the cross product. So this normal vector here is given by this. Now, in order for you to come up with an equation of a plane, set up a point in the middle of nowhere. So this is our general point. We need to demand that the general point here, if you get the dot product of the normal vector and dot it with our general point, we need to demand that it is at 90 degrees. So our next step is to work out the vector from B to our general point here. Because if you just simply use X, Y, and Z, that's from the origin to there. But the B is our center of the universe. We centered everything from B, because if you set up, remember, we set up our vector from B to C and from B to A. So everything's centered at B. So for our general pointer, even the normal line here is centered at B. So we need to center everything at B. So we need to get from B, we need to get the vector from B to our general point here. So the vector from B. So currently I'm at B. How would I get to this general point P? Well, I would need to get x take away 2, and I would need to get y take away 0. I need to get z take away 0. So this vector here is from B to your general point. And remember, we need to demand that the dot product of our normal vector, this is our normal vector. So remember, normal vector here is 3, 2, 6. This is our normal vector. So we need to demand that the dot product of the normal vector and the vector from B to our general point, which is this vector here, we need to demand that the dot product of the two must equal 0. So now if you compute this, remember to compute the dot product, it would be this times this, plus this times this, and then plus this times this. And we need to demand that this whole thing here equals 0. So now tidy this up. That will then give you this. And something I forgot to mention in the previous video. Notice that the coefficients here are the same as your normal vector. So this is your normal vector. 3, 2, 6. And then down here you've got 3, 2, 6. So up here you've got a single number. So you normally chuck all your single numbers on the other side. So it looks neater. So now this is your equation for that plane.